What's going on, guys? Let's do this problem right here. The question is asking, the first question that's asking a 400 watts computer plus monitor is turned on 8 hours per day. If electricity costs 10 cents per kilowatt hour, how much does it cost to run the computer annually? Right? So that's the question. So how much does it cost to run the computer annually? So let's see how we can find that one. So first of all, they are talking about kilowatt hour, 10 cents per kilowatt hour. So let's see how we can convert this given information into kilowatt hour. And if you notice, we have watts provided. So power is equal to 400 watts, and the time is provided 8 hours per day, right? So 8 hours per day. So to calculate how many watts hour he is using per day, we can simply multiply this one because that's going to give us watt hour. So let's calculate that one. So we can say, let's multiply 4 times 400 times 8 hour. So this is watt, right? Watt times hour, that's going to give us watt hour. So this is going to be 3200 watt hour per day, right? To convert this one into kilowatt hour, we simply can divide this one by 1000, and that's going to give us kilowatt hour. So that's going to be 3.2 kilowatt hour per day. But the question is asking how much does it cost to run the computer annually. So we have to calculate how much kilowatt hour is used annually. To do that one, we simply take this one and multiply by 1 year. So in 1 year, we know that there are 365 days, right? So 365 days. So that's gonna give us how much kilowatt hour per year. And if you calculate this one, that's gonna give you 1168 kilowatt hour per year. Now we know that this much kilowatt hour is used per year. Now all we have to do is simply multiply this amount by this cents, because we have to know how much it cost, right? So the cost is going to be 1168 kilowatt hour per year times 10 cents, or 10 cents. 10 cents is equal to $0.1, right? Because 100 cents is equal to $1. So 10 cents is going to be $0.1. So we simply multiply this one by $0.1, and that's going to give us in dollars 116.8, and that's how much it cost per year, right? And that's how we do this kind of problems. And let's look at the second problem. So we have this second problem right here. That's asking, in a certain electroplating process, gold is deposited by using a current 14 ampere 19 minutes for 90 minutes. A gold iron Ag plus has a mass of 3.3 times 10 to the power minus 2. So this is multiplication times 10 to the power minus 2. How many grams of gold are deposited by this process? So they are asking for the mass of this gold. So the first thing here, what we can do is we can calculate this one charge, right? Since we have I that is provided 14 ampere, and also time is provided 90 minutes. So we know that IT is equal, Q is equal to IT. That's going to help us to find the charge. And let's see how the charge is going to help us to find the gun, right? That's what we have to figure out. Because we can calculate charge, then we have to know why we are calculating the charge. So first of all, we know that in electrons charge, if I take electrons charge, that's going to be 1.6 times 10 to the power minus 22. So this is going to be per 1 coulomb. right? So here we have this information. Let's see. 10 to the power, actually it's 10 to the power of minus 19. 19, and from this one we can calculate the charge. So from this information we can calculate how many electrons this charge have. If I can find that one and then multiply by this number right here, because they have given the mass of Ag. So if I multiply that number by this one, that's going to give us the mass of the gold. So let's calculate charge. So the charge is going to help us. So let's calculate the charge first. So this is going to 40 ampere. I can write 40 coulombs per second, because ampere is equal to coulombs per second. Same thing. Coulomb per second times 19 minutes times, to convert minutes into second, I multiply this one by 60. Second cancels and we get answer in coulomb. So if you multiply, you will get 15960 coulomb, right? So this is the charge we have. Now we have to know how many electrons in this charge. We know the charge of one electron. This is 1.6 10 to the power times 10 to the power minus 19 coulomb. Also positive negative charge also carry same amount of coulomb. So to find the total negative charges, we use this equation, like we can divide this value 15960 divided by 1.6 times 10 to the power minus 90 is going to give us the number of electrons. And if you divide this one, that's going to give you 9.975 times 10 to the power 22 electrons. So this much electrons we have in this charge. So this is coulomb, 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 coulomb cancels, and this is electrons. The answer is going to be electrons. So this is what we get. All we have to do is simply multiply this one, mass of Ag gold ion, by these electrons. So let's do this one. So total gold deposited is going to be equal to 9.975 times 10 to the power of 22 times this mass, that is 3.3. So this is electrons, 3.3 times 10 to the power of minus 22 gram, right? So here if we notice 10 to the power of 22, 10 to the power of minus 22 cancels, and this one is approximately 10, right? Almost 10. 10 times 3.3, that's going to be 33, approximately 33 gram. So that matches the E answer. So the answer for the second question is going to be answer E. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.